Hello and welcome. We are live from Form Next. It's the end of day 2. My knees are starting to ache. I think my voice is going a little bit, but we're hanging in there. The booth is still pretty packed of a bunch of folks really seeing what's new in additive, the trends in the industry. I'm delighted now to introduce my friend, industrial expert, in-house innovator, engineering enabler, and general all-round additive champion to the automotive industry, Fadi Abro, Global Director of Transportation. Fadi, good to have you with us.
Thank you. What an intro.
I know, right? We've got to live up to it.
Thank you.
No pressure. So I just wanted to start by saying, what's the day-to-day look like for Fadi? Tell us a little bit about your role, how you work with the automotive industry.
I wake up at about noon.
Nice.
No, look, for me, my mission and my goal and my team's responsibility is about driving innovation, additive innovation inside the automotive space. So at the end of the day, what we're looking for is... All right, let's try that again.
It's live.
It's live. I feel like I'm on SNL. Okay, so what's the day-to-day look like? My mission, my team's mission is all about driving innovation inside the automotive space with additive specifically. So at the end of the day, we want the automakers to leverage this tool that they have in their tool belt. It doesn't mean that legacy manufacturing goes away. It doesn't mean other automation things go away. This is an enabler of all of that. So that is my day-to-day. That's what I'm focused on. We do it globally. I'm lucky enough to have teams here in Germany, teams in the US, that are all dedicated to that, working with the biggest brands across the globe.
And it's an interesting one for the automotive industry. They're kind of at a pivot point, moving into electrification, presenting a lot of kind of new challenges for them that they've not been to before. How's additive kind of uniquely positioned there to help them out with some of those challenges?
Yeah, it's a tough question, right? So undoubtedly, and if you've ever heard me talk before, you've heard me talk about electrification.
Yeah.
That is the move. That's what everyone is focused on. And that forces the automakers to create new designs, new vehicles. And then it also forces them to create new plants, new ways of putting the car together, new manufacturing methods, while all at the same time having an initial lower volume. And then also a demand from the consumers to have mass customization.
Yeah, absolutely.
So there is a ton. I mean, think about like your iPhone.
Yeah.
You have a unique case. I have a unique, even though we maybe have the same phone. And I bet if we walked around here, we would have a hard time finding two identical cases, right? So people want to customize. They're okay with the initial base unit, but they want customization.
Yeah. Make it more about me, sort of thing, right?
That is right.
Now,
it has nothing to do with age either. Don't apply that to the younger generation.
Yeah,
it has nothing to do with age.
That's it. Absolutely. Good point. So let's talk about some of the applications. I just wanted to start by saying, Stratasys has 5 technologies here, 5 different additive manufacturing technologies. I think over about 150 materials. Is it a one size fits all? Obviously not. But is there any one technology that lends itself to additive, to automotive? Beg your pardon.
Yeah. Look, if one size did truly fit all, we wouldn't need 5 technologies, right? So I always remind customers of that. And it's why all these technologies exist. I don't know how many exhibitors are here. I mean, hundreds. Right?
800, actually. 800 plus.
Okay, so nearly 1,000 exhibitors. Yeah. So the solutions are unique. The solutions are diverse in this industry. Yeah. And there is a right fit for different applications. What we've done at Stratasys is created a portfolio that captures everything an automaker could ever need in terms of polymer printing. Yeah. Okay? So we go back to the applications. In automotive, if we're designing a new car, we need to make prototypes, things we've done for a long time. Prototyping's been around for a long time. It's not going away. New cars come out every year. Those are being designed via additive and prototype via additive. So when it comes to prototyping, all of that is still happening on a daily basis. What are the right technologies for that? It tends to be technology that could have a good surface finish like SL for us, like our Neo 800. It could be things that have a multitude of colors and textures like our PolyJet technology. If I look at an example like this, this is a component that has a wood grain imaging on it. It has a leather texture on it. It has stitching on it. It has an image on the top. All of that was done in a single print.
Yeah, sure.
And so it reduces the time to market. You can get to market faster by implementing kind of all these bonus features into your prototype. If you look at manufacturing, how is the car being put together? Automakers are struggling. If you go and order a car today, you might have to wait several months, maybe a year,
sometimes years, right?
Yes. And so if you look at that and you think, what could additive do? What does additive have to even do with that? Right? We are enabling the production of vehicles with jigs, fixtures, tooling, assembly aids, automation, all the things that you need to put the car together. I'll give you an example. This is a badge locator. So this helps you align the badge on a vehicle. This tool is lighter, cheaper, faster to make. You can iterate it, you can customize it, you can make it more ergonomic. All of that is happening at the factory level, and it's enabling you to get more cars out the door. Right. If you can get 12 vehicles a day, that's $1 million a day in revenue.
Oh yeah. Right. Yeah. And here's something I always wanted to ask someone like you that works so closely with automakers is how they have additive set up within the industry, within their companies. Is it a case of they have it on the production line? Is it kind of a centralized bureau that people will send their prints to? Is it, every designer will have one next to their desk and, they're just printing things all day, trying it out? Like, how does that work?
It's a good question, and it actually ties to the product line. I didn't even finish my thought. So on the ability to connect technology to application, for these kind of production jigs and fixtures, FDM is the right solution. On the production side, we have technologies like SAF, and I'll talk about this in a second, that can enable high volume production, origin, high volume production. So it depends on where you land. In terms of where the equipment sits, that's also a unique challenge for automotive. Because what do? Do you put a center of excellence for additive that supports the whole organization?
Right.
Or do you put the innovation where the innovator is? So in the case of FDM, it's used on the production line. So should you put an FDM machine in the production plant? So that you can quickly make a tool if you need a tool, right? Most companies that are investing heavily in additive are implementing kind of a hub and spoke strategy. So you do have that center of excellence because there are technologies that require an infrastructure. Powder technologies require an infrastructure that you don't want to establish at an assembly plant. But FDM is plug and play. You can drop it in a plant, and then you enable. I always say, you're putting the innovation and the innovators together.
Yeah, gotcha. So let's jump into some applications and what we've got on the table here behind us. I don't know where you want to start. I mean, we've got colorful, we've got high volume. It's intoxicating, right? Everyone's just being drawn over here. Absolutely.
So look, I mentioned some jigs and fixtures applications. I mentioned some prototype applications. I do want to mention one application that I think is incredibly cool, which is wind tunnel models. So this lives in the prototype world because you're testing a design. So I would still call it a prototype. But this is F1. So, we're all addicted to F1 now after watching Netflix.
Absolutely. That's right.
This particular material enables you to run this through a wind tunnel model. It's incredibly stiff, and also the surface finish is incredibly
it is unbelievable.
So you're taking a representation of a production part or a production design, and you're validating it in the wind tunnel within hours. And in F1, seconds matter.
Amazing.
Right. So if you can win on the wind tunnel, then you can win on the track. Right.
Absolutely. And does that apply into other Formula racing categories?
Across the board, across the board. All racing divisions and traditionally manufactured vehicles all have to go through wind tunnel model testing, right? But especially when you talk about EV, you're talking about a mile of range extra if you tweak something. So these guys are doing all that. As far as other applications, I promised I'd come back to this, so I will. This is an actual production part for an aftermarket company called Roush in the States. This is their entire week's worth of production. It's about 54 parts. They need about 50 a week. It's an aftermarket component. They decided this part is actually going to be easier to and more economical to manufacture in our powder technology and our SAF technology than to go with an injection mold. Because their volumes were lower and the design was fairly complex. But right here, you have an entire week's worth of production in 13 and a half hours.
Wow.
So in 13 and a half hours, they do one print, They have the whole week's production,
Yeah.
and they can use the system for other things, including prototypes or
Yeah.
tooling or whatever else you need.
Because it's not just about cost per part, which, you know, we're getting down on that. It's also about reducing the amount of processes, right? There's less assembly.
Yes.
So if you do have a complex part, you're not now putting together, you know, 10 components. You can put it in one component. That's a big step forward for these guys.
Consolidation's key, and time to market is key.
Yeah.
If this company, Roush, has trucks on the line waiting for a single component, that is bad business. Right? Get these parts printed, get the trucks out, make your money.
Yeah, absolutely. And talk to us. I see a lot of the fabrics.
Yeah.
That's drawing my eye in. Yeah. So, talk us through some of those.
Well, let's talk about that, because it is interesting, and we've had a lot of questions about it.
Yeah.
So, with production printing, you're typically talking about lower volumes, and automakers are having lower volumes on certain models, right?
Yeah.
But when you talk about fabrics, you're talking about mass customization.
Yeah.
Right. That's another huge request. We talked about it at the beginning.
Yeah.
So you can do really unique things. I'm not sure if this is coming through on camera, but you're getting a lenticular effect with this. This is a panel that would be on the dashboard on the passenger side. Just something interesting rather than a flat panel, right? And you can customize it to a particular vehicle, a particular year. You can decide the first 10 of this vehicle are going to be special and have this green trim with this printed texture on it. So this is using our PolyJet technology. So you have a piece of fabric that we then 3D print on top of, and then we can do whatever you would do with a normal piece of fabric after that.
I gotcha. And I've got a windscreen reservoir behind us.
Yes.
Bit of a sneak peek, maybe. An exclusive.
I hope no one is watching, because this is somewhat of a secret. So we are, with our powder technology, which again will drive the adoption of production in automotive, we're introducing polypropylene. Now, polypropylene is one of the most widely used plastics on the globe. It's one of the most widely used plastics in automotive. So it's a really nice marriage of this additional material into this technology that can make a lot of parts. So polypropylene coming soon on SAF. Stay tuned for that.
Heard it here first. So another thing I wanted to talk about was the design side. So we look at the challenge of the EV industry, right?
Sure.
You know, we talked about the aerodynamics, you know, extra range on cars, because everyone's got that range anxiety going on. But I wanted to ask about lightweighting as well, and how additive can play into lightweighting.
Yeah. Absolutely. So, you know, with additive, the old trope around additive is complexity is free. Which is mostly true. You can get as complex as you want, and it's not going to cost you much because the design, the way that it's layer manufactured, allows for that. So where that truly translates into tangible results is if you're making a tool or a jig or a fixture, and you want to reduce the weight on that, because you got an operator that's working on it all day, every day.
I gotcha.
The other place is inside the vehicle. So where are opportunities to reduce weight? Certainly on the metal side, that's probably more impactful. But even in plastics, we have the opportunity to do that at the drop of a hat with generative design, clever designing techniques, all of that. Absolutely. And again, range anxiety is a real thing. It's holding the industry back. So if we can get 5 more miles because we tweaked a design, that's worth it.
Yeah, absolutely. And I mean, it's not just you know, and other methods of transportation are available, right? It's not just EV. I think, you know, aerospace is looking at lightweighting as well.
And in aerospace, it's much more impactful because you're talking about ounces on a plane. Absolutely,
So related to that, I wanted to ask you about metal replacement opportunities. That's kind of a common phrase I often hear from automakers. You know, it kind of comes into the lightweighting play as well, but if you can swap out a metal part for a plastic or a polymer, you know, it kind of makes sense to identify those opportunities. That's kind of what these guys are looking at.
Look, absolutely. Think about the fact that bumpers used to be made out of steel. They're not made out of steel anymore.
Absolutely.
Right? So there is an opportunity to translate one-to-one. A lot of characterization has to happen. We're not here to pretend like things are easy. Right? We're here to just tell you that it is a viable option. There are opportunities, clips, wire management, things inside the vehicle that maybe are metal brackets, that could be plastic brackets with little to no impact to the performance of the vehicle, with the exception of making it lighter weight. Another impactful place I know I keep bringing it up, but another impactful place where lightweighting means a lot is in tooling. If you have an operator using it and it's made out of metal, does it need to be made out of metal? We have use cases where we're taking out 100 pounds out of a tool
Wow. Okay,
It doesn't have to be metal. It was only metal because that's just our imagination.
It's the mindset.
Exactly.
Changing the mindset. Yeah, and so we've talked about additive technologies, materials. I wanted to switch gears and go to software.
Sure.
So, we've recently bought out GrabCAD Print Pro, a lot more kind of automation within that. So it's allowing the design cycle. How's that kind of playing into the automotive industry and helping these guys, be more productive?
Right. So look, in auto, it's all about speed.
Yeah.
I need everything yesterday. You're too late. If you got it to me today, I need it yesterday.
Yeah.
So with software, one thing we've done is enabled the software to be much more user-friendly. So now you can take a fairly novice user in additive, and they could take their 3D CAD and turn it into a printable file very, very easily. We've made the user interface for doing that on any 5 of our technologies incredibly simple.
Yeah, sure.
So that was kind of the first obvious step. Right? There are slicers out there. There's really complicated software. That's not what we're doing. Yeah. We are the plug-and-play company. We want it to make it as easy on you as possible. Yeah. Then the other piece is on how you manage your fleet of equipment. So our software enables you to manage your entire fleet. I have a queue of 10 builds on this. I have a queue of 3 builds on that. What am I going to schedule next? Again, enabling productivity, 0 downtime, 100% utilization, all that. Then the third element, which is fairly new for us, is enabling plugins that will give users extra functionality. We are not going to build every functionality imaginable in the software. But there is an opportunity for us to say, okay, if Automotive likes this FEA tool, it's a plugin. We'll work with the ones that they like and trust, and we'll plug them into our software. If there's aerospace standards that need to be measured for fatigue or other things, we plug that right into our standard.
Gotcha.
And that's really been the new and exciting thing for us, is kind of opening up our software and plugging in.
Now, I should have included in the intro industry veteran as well, because you have a lot of experience there. So I wanted to ask you, the changes that we've seen over the last 5 years, quite marked. But if you had to kind of put some glasses on and guess what the next 5 years is going to look like, what comes to mind?
I specifically wrote in my intro, industry veteran. You didn't read that thing?
Yeah, I'm sorry about that. Missed it. It's live.
Look, I think I've been in additive for 13 years. Okay. I'd say in the past 7 years, it's been all about material development. You have companies like BASF, who are partners of ours. You have companies like Loctite, who are partners of ours. Covestro, who we just acquired. There's a lot of material companies that are doing great things outside of Stratasys, and we happily welcome them into our ecosystem because they're trusted by the OEMs and everybody else, right? So I'd say the past 7 years have been all about material development, really characterizing materials, improving materials, etc. And so what do the next 5 years look like? The next 5 years, I would say, are all about throughput. How do we get more parts off of our equipment? And we're doing a lot around on that front, so stay tuned for that too. Yeah,
absolutely. And it kind of leads into this. I was going to ask, what can the additive industry do to help automakers? Is it automation, sustainability, maybe multi-material printing? You could have metal and plastics all in the same.
You made my last question really hard. Thank you.
No, you've got more after this. I
think we're getting the red light.
Yeah, all right. Okay.
So
so if you had no limits on it, like what would you like to see?
I would say that most importantly for auto is throughput and cost per part. Yeah, those are things we have to work on as an industry. I would say third would be around material characterization and getting materials characterized in the same way that injection molded materials are characterized. That's very important, and it's hard to get a part on a car without that, right? So those would probably be the top 3, I would say.
Fadi, I've loved chatting to you. Thanks ever so much for joining us from LinkedIn Live.
Thank you.
And thanks everyone else for joining us live. We're having a great time here. I think it's time for us to go and have a beer. Relax,
our voices are gone.
For me to try and get my voice back. Please hit us up. #AddStratasys, #make additive work for you. Leave some questions in the comments. Fadi and I will go through them later and try and answer them. But I hope you've enjoyed it. And we'll either see you on the booth or see you around. Take care.